Hey everyone, welcome back to Mr. Holland's Classroom, where today we are doing lesson 2 of chapter 12. It's the last chapter in my math, so it's going to be in your second math book for kindergarten. We are still talking about 3D shapes or solid shapes. Yesterday we talked about spheres and cubes and how they're different than circles and squares. They are related, but circles and squares are two-dimensional shapes, whereas spheres and cubes are three-dimensional shapes. And we've got two more three-dimensional shapes today. We're talking about cylinders and cones. Cones is probably going to be an easy one because we see cones all the time. We see traffic cones, we see ice cream cones. Everyone knows what an ice cream cone is, and if you don't, you're missing out. But traffic cones, ice cream cones, like party hats, those are examples of cones. And cylinders, well, we see cylinders all the time too. Guess what this is? A cylinder. Guess what your pop can is? Or if you're not in the Midwest, a soda can. It's a cylinder. I was showing yesterday, this battery is a cylinder. This marker is a cylinder. This jar is a cylinder. This flashlight's a cylinder. Oh, we got so many cylinders. All right. So anyway, glue stick's a cylinder. All right. Anyway, let's get into this lesson before I start getting too crazy. Okay. So we're still talking about how do we identify what's a three-dimensional shape. We see that these two shapes, this is a square, and this is still a square, even though it's rotated, but the square is two-dimensional. You can see how its length and its width. But with three-dimensional shapes like a cube, there's length, width, and height. Let's check it out. Look into these shapes. Okay, it says describe characteristics of cylinders and cones. While I don't have an example of a cylinder with me, cylinder, I mean cone. I don't have a cone with me because I brought an ice cream cone, but I got really hungry and I ate it. But anyway, but you can still, actually, you can make a cone. Take a piece of paper, and if you kind of roll it around, kind of like you're making a megaphone, kind of like you see how I'm rolling it a little bit like this on the inside, rolling it around, rolling it around, rolling it around, and there you go. So it's a very skinny cone. I can make it even fatter, but looking at these, what are the characteristics? Well, they both look like they could sit down if I put them on a table. Like if you put an ice cream cone upside down, or let's just think of a traffic cone, you can put them down on the ground and they will stay sitting on the ground. Remember how we talked about yesterday? If you put a sphere on the ground, what will happen to it? It would just roll away because it doesn't have a flat face to sit on. It would just keep rolling. So I'm done trying to make that cone. But you can set them down. The cylinder has two of those flat sides, so you can flip it over and set it down like a pop can. You can flip it over and it would still sit up. If you put a cone upside down and if you try to sit your ice cream cone down with the ice cream on top, what's it going to do? It's going to fall over because it has nothing to sit on. Also, if you put these both on their sides, I'm thinking they'd probably roll around. The pop can, if you've ever dropped the pop can on the ground and it kind of rolled and started getting all fizzy and all that kind of stuff, you know that's true. But with the cone, it would, if you set one down on the ground like a party hat, you set on the ground, and the wind was blowing, it would just kind of roll around in circle. It wouldn't roll away. It would just stay in place and roll around. So anyway, talking about that a little later. Anyway, we did this yesterday. Draw lines to match the solids to the real world shapes. And remember, they're saying solid, which also means three-dimensional. Three-dimensional, solid, it's the same thing. So let's take a look at our examples. So, look, they have the party hat on here. And they have the traffic cone. Didn't I already use those examples? Oh, but I didn't think about this one. So for the cylinder, they have peanut butter. Oh, the peanut butter jar. Love that. And they have tomato soup. So soup cans, also good examples of cylinders. We see these all the time, people. We know what these are. So on this page in your math lesson, they have that. Oh, look at the ice cream. Who was talking about that? Psh, this one. Anyway, so what they want you to do is draw examples of these shapes. So the cylinder, what are you going to draw over here? Pop can, soda can, pop can, tomato, soup can, peanut butter jar, flashlight, whatever, those the glue stick, you can draw those things, they would match. And then on the bottom, ice cream cone is an example. Like I said, a party hat example, or a traffic cone. Those are examples of cones. See, cones is really easy one. We know what cones are. We think of ice cream cone. As soon as you hear the word cone, you think of ice cream. I'm not lying. You know it's true. So go ahead and draw some of those things on there. And then when you flip to the next page, it's just like yesterday's homework where you have to circle the object that matches. So obviously with the cylinder, hey, look, a battery. Who's talking about the battery? This one. All right. So that is a cylinder. Can you say cylinder? Now, if someone asked you to spell cylinder, it would be very tricky. This is another hard word to spell because it sounds like an S, but it's CYL, cylinder. Um, so that one would be tricky. But cone, you could probably do cone with that long vowel sound and that sneaky E right there. Yep. So this one says find the cone. Well, this thread is on a cylinder container, and this is a cone shaped object. It's a block. But all right, so cylinder down here. What do we have? None of these really look like pop cans or anything. We know this is a sphere, so we're not gonna do that. It's round. And then this, it looks like a box. It's a tissue box. And remember, we were talking about box shapes yesterday. This actually isn't a cube, though. We'll talk about that later. But it's not that. You might be wondering, it's like, this tuna? But it comes in a can and it has two flat sides and is round on the outside. So yes, this is a cylinder. It's a short one, yes, but it's still a cylinder. What about cones? Are they trying to surprise us here? No, not really. This bowling ball, sphere. This party hat, what are we talking about? This tomato can, we already know that is a cylinder. So no tricking us on this one. All right, let's go over. Yep. Okay. There's more of the same. I'm not going to do these to guys. I'm not going to do these for you guys. You guys are going to be able to do it because really, we're not asking much. This is really easy. What's the cone? What's the cylinder? Just make sure that you're on the right one because if you come down here and you're like, oh, I see a cylinder. Here it is. And it's like, no, they were looking for a cone. Make sure that you're looking for the right shape and they don't trick you. Okay. Say, well, ooh, crayons. Like a perfect examples of cylinders and cones. The top of a pencil or a pen, even depending on what kind of pen you have, or a crayon. Look, it's got that cylinder shape. If you chopped off the top of the pencil and you do that, you got it right there. All right. Yep. And the homework is more of the same. Just make sure you don't get tricked. And down here where it says cylinder and cone, make sure cylinder and number 7, you draw a cylinder on this side and you draw a cone on this side. You might not be able to read what cylinder says, but cone, you should be able to read what cone is. And you will know to put that over here. So then we'll get to the next lesson tomorrow. But until then, I'll see you later. Bye, everyone.